to understand quantum concepts. Khalid Bentaleb, Abdelhamid Lechhab, Fouad El-Hars, Elmahjoub Chakir, Taoufik Hassouni, and Elmehdi Alibrahmi from Faculty of Sciences University, Ibn Tofail in Morocco.
Okay, good morning, ladies and gentlemen. Today I will share with you my work with title about study the difficulties, innovation to rise difficulties of the teaching, learning, quantum mechanics, computer simulation, programming, computer games, and cartoons to understand quantum concepts. It's very clear. It's very clear. It's very clear.
Yes.
It's very clear. Yes. Okay.
Yes. Yes.
I will. Yes. Okay. I will follow this plan. I will start by introduction, where I show the importance of quantum mechanics and teaching learning quantum mechanics. I will present also the problematic of study based in 2 points: difficulties in teaching learning quantum concepts and learning's misconception. And the remedies is innovation for teaching learning quantum concepts are visualization, simulation, programming, cartoons, game, result, and discussion. And I will close by conclusion. Sorry. In introduction, why quantum mechanics is important? Quantum mechanics is important because explain what classical physics could not, like photoelectric effect, quantum effect, stability of the atom. And generally, quantum mechanics explain phenomena at the subatomic scale and giving the emerging application like semiconductor laser, quantum cryptography, quantum computer, quantum computing, Bose-Einstein application, giving this reason, quantum mechanics is very important for teaching. And given the importance of application based in quantum mechanics, especially today, quantum computer and nanotechnology, this is the teaching of quantum mechanics is integrated in several cycles and fields of study, in undergraduate and master cycles, in engineering cycles, in high school, in preparatory classes, and in pre-service teacher training, and in training of researchers. But the difficulties, the problematic is the teaching learning quantum concepts isn't an easy task. It's very, very difficult task. Why? Because the quantum concepts are too abstract, counterintuitive, far from the learner's daily life, and with difficult mathematical formalism. And it is also a lack of experiment in quantum mechanics. And also, this is also another problem with teaching learning quantum mechanics is learning's misconception. In this picture, for example, the teacher try to teach that electron is in the same time is a wave and particle, but the learning conceive this concept in a different way. They developed a different misconception. Now, a lot of researchers, a lot of study have studied the difficulty in teaching and learning quantum concepts. And the question now, how to help students, how to help learners improve their understanding of quantum concepts. In this picture, for the student or learning, how to improve, how to help him to better understand a lot of concepts in quantum mechanics, like meaning of wave function, principle of superposition, Civil researcher for answer this question, civil researcher have proposed remedies innovation in teaching quantum mechanics like simulation and visualization, programming, cartoons, games, videos for help students to better understand quantum mechanics. I will start now by the first remedies, simulation and visualization. A lot of researchers have developed some projects like FET, Quills, Quivis, and Relicant. In Project Quills, for developed tools of simulation, they're based in the investigation of difficulty of learning quantum concepts. And the researchers have developed quantum interactive learning tutorial. For example, Anderson development of wave function, the uncertainty principle, the mass, gender, and interferometer. An example for simulation in Project Quills. In this example, the learner can visualize and then understand that in case A, this is a probability density. In this case, the probability density not evolve with time because this is a stationary state. But in case B, we say very well that this state is a superposite state. It's a non-stationary state evolve with time. In this simulation, the learning can understand very well the difference between a stationary state in case A and a non-stationary state in case B. Another example for this state is a superposition with two states, psi1 and psi2. And with this simulation, the student can understand very well that the measurement is a probabilistic process. Thus, the measurement give two possibilities measurements. E1 and E2, E1 with 20% and E2 with 80%. Another simulation is about photoelectric effect. With this interaction simulation, the learner can change the wavelength for understand the photoelectric effect. And the aims for this simulation, the answer said the corpuscular aspect of the light. The learner interact with the simulation to finally understand that the light is made of energy quanta Khalid photons. And also the learners invited to do this task, the response for this question. Another example in simulation for understand the behavior of wave packet or a wave function across a barrier potential. These interactive simulation example allow the student to visualize how a wave function crosses a potential. In another work, some researchers have developed a simulation for understand very well the orbitals atomic in atom. And the answer that imagine the probabilistic aspect of the wave function of the electron on the atomic orbitals. And the question now, what is the value provided? What is the value provided for using simulation and visualization? In this example, the learners can very well understand the difference between, for example, between an infinity barrier potential and finite barrier potential. The learners, by manipulating quantum system, he can very well understand and visualize well the difference of the quantum state between these two cases. Another example that simulation allows the student to interact with simulation and to to do some task. For example, in this case, the learners invited the response for this task. Another remedies, another solution for helping students to learning quantum mechanics is programming. While other research have been proposed programming using MATLAB, Maple, Python language, and for example, the behavior, visualize the behavior of wave packet when crossing a potential barrier operator. The researcher have developed or succeed to following MATLAB code. When coding this program, the result is very clear. The learners can see very well the behavior of a wave packet when crossing a potential in these points. Another example in programming with using Maple. We found the Maple code that allowed to visualize the passage of a wave function from a potential barrier. And we see the result for coding this program. This another example who show the behavior of a wave function crossing a barrier potential. And another remedies is using the cartoons. This example is very used in high school, for example. It is a conversation between a boys asking the boy, and the boy he explained the boys the here contribution that a matter a corpuscle or particle moved with a velocity have with him a wave aspects. In another picture, this is Schrödinger. He explained to boys his famous equation about development of wave function with time. Another remedies, another solution is games. In another work by Gordon, he proposed these games. In these games, with playing, the learning can very well understand some quantum concepts like superposition, measurement in quantum, interference, and entanglement. The player will develop a deeper understanding of the quantum world while at the same time have a lot of fun. And in a resultant discussion, then the use of the simulation tools mentioned below have shown that there is a very important improvement of their integration in quantum mechanics teaching. Thus, the use of quantum simulation in zoo study have shown the following results. After using the simulation quills in Project Quill, they have a growing result after using simulation than the traditionally lecture only. This is here we have 13%, but he's 87.8%. In another study, after use the project Quill simulation, they have a comparison with the pre-test score and post-test score, and we say very well that after using simulation quills, they have a growing results. And in study, Gordon study, who they use the games after using games, they have a growing result of correct response. In study, the research in study Gong 2015, the research investigate effectiveness of using simulation when teaching student quantum concepts and asking the following question: what is the best way for you to study quantum mechanics and its concepts? Have you ever used simulation for learning purpose? Do you think simulation help your study? Why or why not? In this study, the study allowed the following results. Almost all students had a positive attitude toward using simulation. Simulation are an effective analogic and visualization tool to interactively and effectively engage students and to introductory quantum mechanics course. But, however, simulation also have some limitation. In conclusion, given the complex nature of the discipline of quantum mechanics, difficult level of abstraction, not intuitive quantum concepts, difficult mathematical formalism, persistence of classical paradigms, then to overcome this difficulty, several tools have been developed, such as computer simulation, programming, and cartoons, active and motivating method in class. Also, author proposes for remedies is the practice teaching must be changed for active, motivating, and interactive methods without introduction of discussing the interpretation of quantum concept. Also, the revision of program and content is a primary necessity. Also, it is necessary to early introduce to quantum mechanics in high school curriculum. And thank you very well for your attention.